All right, guys, so we're doing a next little subheading with a 1302. Now, if you look at it, it's solving dy dx equals function g of y, not function of x. So that's just something that you need to keep thinking about while we're doing this, all right? And example 4, it says find the direction field for the differential equation dy dx equals 8y, not 8x, 8y. So that will be something, different things will happen with direction field because it's now in terms of y, not x. So that will be a little bit different. So let's see what happens with that. Okay, so dy dx, dy dx is our gradient, so I'm going to call it as a little m equals 8y. It'll be the same sort of principle. So I'm still going to use the table to do it. I mean, you can use the, not the vertical table, you can use the horizontal table if you want to. I think you're probably more familiar with that. So I'll put, instead of x on here, if I don't know whether you can see cursor here. So y, I've got 0, 1, minus 1, 2 values there. And then m, the second column, I'll put the m there. Now, m is when I substitute the y value into the 8y, what will I get? Now, this is not our actual normal value, it's the gradient, okay? The reason we are looking at here is a couple of things. The direction, like a plus minus, like a positive direction, negative direction. And another thing is the pattern here. As you can see, when it's a 1, its gradient is 8, but when y value is 2, gradient is 16. So there's a big jump there. It's growing, right? It's getting steeper. So that means automatically it's vertically, like straight up. All right, remember when we get to gradient gets bigger, it's vertically going up. When it's smaller, it's flattening out. And also, so that means when I looked at the 1, it's 8, minus 1 is minus 8. So it's opposite directions. Okay, it's not the same direction, opposite. And also, the 0 value is sort of, turning point. Now, this time, it's not going to be on the y-axis. It's going to be x-axis. So if you look at the left-hand side here, the number plane here, instead of put the stationary point or turning point on the y-axis, I'll put it on the x-axis this time, okay, because it's y equals 0, okay? So, and then I didn't put vertically, I'll put a flatten out, okay? And then what will happen after that is y value equals 1, the gradient is 8, so it's positive. So I'm going to looking at the first quadrant and second quadrant, it's going to the positive, to the right hand side corner direction. But if you look at below x-axis, my gradients will be opposite direction, to the left, the negative direction, okay? So I've done that, and then it gets steeper, and eventually it's going to be vertically straight up, sort of. That's roughly similar to what I've got, but much neater. So before we do example 5, you probably noticed that there's something different here. The dy dx, the gradient is still there, but it was in terms of y, not x. So we need to think about this. If we want to integrate from dy dx, but it's in terms of y, it's going to be very hard to do it. So let's have a look at this here. This is the important part. Okay, so that's a dy dx times dx dy equals 1, given that y equals f of x is a differentiable function. Well, that's okay. So that's we know that that's what's going to happen. But now from here, I'm going to make dy dx as the subject. So what happened here equals 1 times, it's going to be flipped over, isn't it? So it's going to be dy dx, or like what it says here, 1 over dx dy. So you're just dividing it by dx dy on both sides, same thing. So remember that, that's what we're going to use. So when you see dy dx, but if it's in terms of y, to be able to integrate properly, we need to flip it. Okay? All right, so let's have a look at the example 5. Do it, solve. Remember, the word solve means we need to change it to original function here, which is y equals. Okay? Now, we probably need to, first thing we need to do here is we have to go to dy dx into change into dx dy. Otherwise, we won't be able to integrate in terms of y. Okay? So I'm going to change that. So now it'll be 1 over 2y, because I'm just flipping it, which is same as 2y. Okay? So that's what happened at this point. And I'm going to do now, so therefore dx equals 2y dy. Now I want that to be x equals, so I'm going to do integrate. So integrate dx, integrate like that, and that whole thing will cancel out, it becomes x, and that's pretty basic one. And don't forget the c at the end, so therefore x equals y squared plus c. Now, that's not what we want, isn't it? It says solve it for the first order differential equation, which it needs to be in terms of y equals. So second, we're going to make y the subject. So make sure you do that. So I'm going to make this, okay, the subject. So I'm going to make this whole thing will be my left-hand side, and that's my right-hand side, because I want the y to be on my left. So if I do that, y squared equals x minus c. Okay, and I don't want a y squared, I wanted y equals. So therefore, plus minus square root of x minus c. Okay, so my equation, original equation, I have got 2 of them. Y equals positive square root of x minus c, or negative square root of x minus c. Okay. Okay. So next one is a same thing we're going to do, but it's a little bit different now. So I'll do the dy dx changing to dx dy first. That will be 1 over 8y. Okay, x equals integrate 1 over 8y dy. But I'm going to take the constants out, and this looks like ln. And don't forget this c. Okay, so that's what I've got. Now, but that's not all, is it? We have to change this one, make the y the subject. So I'm going to times by 8 on both sides, because I don't like the fraction right there. So it's going to be 8x equals ln y plus c. And I'm going to make my ln on my left-hand side. That'll give me, whoops, some 8c minus 8c. Because when you're timesing it, 8, make sure you times the c with the 8 as well. Okay, because it's 8 times bigger now. So in here now, I want to get rid of ln. So I'm doing making it to e. So take times by e there. So I'm going to go y equals e to the power of the whole thing, x minus ac. Now we can sort of simplify a little bit further from here by making it 8x times, you know, the index law. Now, as you can see, this is another constant, isn't it? And then we can name it as a because it says on the textbook there. So I'm going to you can make it into p, you can make it into anything. So therefore, my equation is a times e to the power of 8x. That's my equation for that. Okay, the next one. This one's a bit more exciting because it has actually points there to play around. So we won't have the constant as a c. We'll have a value in this case now. Let's have a look. I'm going to go straight into dx dy because it's in the y term already. So I'm going to go like that. Okay, and this one I don't see I can use log ln. So what I'm going to do is I'm going to change that into index form because it's easier for me when I do integrate. So next step will be I'm going to take the constant out, dy. Okay, well that's just basic integration. So therefore x equals minus 1 5y plus c. Hopefully you can see that from here to there, what happened there. Okay, so that was a first step. Second step, we're going to have to make this in terms of, oh no, we don't have to because we have to find the c, don't we? I forgot about, we got that points there. So find the c. So second step is find the c. Okay, so x is 0. Y is 5 times 1 over 5 plus c equals minus 1 plus c. C equals 1. Therefore, x equals minus 1 over 5y plus 1. Okay, now after this, now we need to convert this one to making the y the subject. Okay, make y the subject. So I'm going to swap this. So I'm going to move my y's on my left. That becomes positive. When I move back, my x becomes negative. Okay, you can just do minus x plus 1 if you want, but I just don't like the negative in the front. Okay, so I want that to be y equals, so I'm going to flip this. Okay, so that's what I've got. And then if I do divided by 5 on both sides, I will get, okay, so that's what I've got. That's my equation. Okay. Part B, let's have a look. This is same, but it's a different expressions there. Now with this f dash x, we can convert that to dy dx. That's not a problem. Okay. And then f of 4 equals 1, we can change that to the point. Okay. This is our x value. That's our y value, isn't it? Because f of x is y equals 1. So it's 4 and 1 we're going to use. And y cannot be 2. All right, so I'm going to go straight into dx dy equals, I flipped, and then I'm going to go x equals 2y minus 4 dy. Okay, so if I do that, that'll be just normal integration. Nice one. So what I've got here is x equals y squared minus 4. Oops, I made a mistake there. Plus c. Okay, so I've got x equals y squared minus 4y plus c. So that was my first step. My second step, I need to find the c using at 4 and 1. So I'll put 4 equals 1 minus 4 plus c, because y is 1, so I don't have to worry about that sort of thing. So this will be 4 equals minus 3 plus c equals 7. So my equation now is x equals y squared minus 4y plus 7. But that's not all, isn't it? We have to convert this one. Converting here. I think I've got just enough space here. So I'm going to put everything on my left-hand side with my y. And then I'm going to move 7 on the other side. Now, how are we going to make this? By completing the square. Okay, so completing the square, I'm going to go y squared minus 4y plus, now half it and square. So it'll be 4 minus 4 x minus 7. And I'm going to break this one because that's my perfect square there. So it'll be y minus 2 square. And I'm going to take this minus 4 to the other side. Becomes 4. So I have y minus 2 square equals x minus 3. All right, that looks pretty good to me. So y minus 2 equals plus minus x minus 3. And then I'm going to do plus 2 on both sides. Then I will have 2 plus minus x minus 3. And again, I will have two equations. Y equals 2 plus root x minus 3. Y equals 2 minus root x minus 3. But you have to think about the condition we had at the beginning of the question. It says here, right there, given f of 4 is 1. Okay, f of 4 equals 1. So let's check whether that actually satisfies it. Okay, so that's y is like f of x, really. So if I put 4 into 2 plus square root of 4 minus 3, okay, will I get 1? Okay, so it'll be 2 plus 1 is 3. It's not 1. So this plus may not work. If it was minus 4 minus 3 equals 2 minus 1 is 1. So it works. So what we can do here is, because of the special condition we had at the beginning, so I'm just going to write here, our final answer is only 2 minus x minus 3. That's only the one it satisfies condition that given at the beginning. So be careful with each question. Okay, great. See ya. Bye.